Okay, chemistry class, let's look at each of the chapters that you're responsible for in the semester 2 review. So I'll start with chapter 12 and work all the way through chapter 20. These will be broken up into individual videos. I'll make one for each of the different chapters. Okay? So let's start with chapter 12. And at the beginning here, you'll notice that I have written kind of the main topics that you are responsible for. So molarity, and I'll just touch on them lightly here, and then we'll work through some of the problems. I won't do the entire problem and work it out. I'm just gonna kind of outline it for you, frame it for you, and then hopefully you'll be able to finish it up. Okay? So molarity and molality, if you remember, those are two types of measurements for concentrations of solutions. Molarity is moles of the solute, that's what you're dissolving, over total liters of the solution. Solution means the solute and the solvent together. Molality is, again, moles of the solute, but this time divided by the kilograms of just the solvent. So maybe that might be water, for example. Ions, remember, those are charged particles, and often when you dissolve a ionic compound into water, it is going to break apart into its ions. So for example, table salt, NaCl, as a solid, when you put that into water, that is going to break apart into its ions. It will ionize, or you might say it will dissociate. Okay? Dissolution just means that you're creating a solution. You're taking a solid and you're putting it into water and you're making a aqueous solution. Okay? An electrolyte is a solution that has ions in it. So if you drink a sports drink, you might see on the side it talks about electrolytes. Those electrolytes basically mean you have ions, charged particles, in your solution. Equilibrium, remember, that is dealing with a reversible reaction. Every reversible reaction is going to reach equilibrium. That means that the forward rate, the reactants turning into products, is equal to the reverse rate, products turning into reactants. When that is true, when the two directions are equal in their rates, you have reached equilibrium. Solubility, that's just a measurement of how much of the solid will actually dissolve in the particular solvent, like water. Often solubility might be measured in grams, the number of grams for 100 grams of water, or maybe it's per liter, or maybe it's per milliliter, but it's basically how much is going to dissolve in a certain quantity of water. And then the factors that affect solubility. If you remember, we talked about different factors that affect solubility. So if you've forgotten those, you want to look back and figure those out. Things like temperature, surface area, the nature of the reactants, or nature of the solid. There are some others, and you're going to want to look back and make sure that you have reviewed all of those factors of solubility. Some are going to dissolve better than others. Some are going to dissolve less than others. So you just want to look at those factors of solubility. Okay? All right, let's just look at a few of these, and you'll notice that all of these problems here are dealing with molarity and molality, and the answers are given to you below. So I'm just going to set these up and just make a few comments on some of these and some of the differences between them to help you work through these. It says determine the molarity of the solution prepared by dissolving a certain mass of citric acid, they give you the formula, in water, and then diluting the resultant solution to that. This is the total solution volume right there. It says you are adding water in order to get a total solution of 3,500 milliliters. Okay? So you have 141.6 grams over 3,500 milliliters, but you want your answer to be in moles per liter. So you've got to change grams to moles, This is going to be the molar mass of that citric acid. You got to figure that out. And then you want to change milliliters. There are 1,000 milliliters per liter. You want to change milliliters to liters. You do that calculation after you figured out the molar mass, and you will have the answer here in moles per liter. Molarity of a salt solution made by dissolving. Again, you've got a mass and you have a volume. It says here, assume that the final volume is the same as the final volume of the water. Basically what they're saying is, here they're only giving you the volume of the water, not the total solution. But they're saying, okay, so you add a little salt, that's not going to change the volume dramatically. Let's just go ahead and use the volume of the water. Same thing here. You're going to take your 280 milligrams for 2 milliliters, and you're going to change it to moles per liter. So you have to change the milligrams to grams, and there are 1,000 milligrams per gram, and then you're going to change grams using the molar mass to moles, and then you're going to have to change the milliliters to liters. So once you've done all of that, you should have your answer in moles per liter. Molarity again, and they're giving you mass and volume. So I'm not going to walk through all of this one. You got to change grams to moles, and you have to change milliliters to liters. Using the molar mass here, we'll change the mass to the moles. What mass, now they're asking what mass of this particular compound, glucose, would be required to prepare that concentration, or actually that volume of that concentration. So what they're doing here is they are giving you, in this definition for molarity, they're giving you the molarity and they're giving you the volume. You would have to figure out moles, and once you have moles, you would then change that to grams by multiplying by the molar mass of glucose. So you plug in your concentration right here, you plug in the volume right there, solve for moles, and then use your moles and convert that to grams by multiplying by the molar mass. Same problem here. What mass would be required to prepare? And they give you a volume and they give you concentration. You're going to have to change this volume to liters because molarity is moles per liter. So it's the same idea. You're going to take this concentration, that is your concentration there, change this to liters, that's your volume, find the number of moles, and once you've found the number of moles, you are going to find the mass of magnesium bromide. If you don't know the formula for magnesium bromide, you should be able to figure it out. Bromide forms a -1 ion, magnesium is a +2, so the formula is going to be MgBr2. You need to find the molar mass of that compound. Okay? What mass of ammonium chloride, NH4, that's a -1 ion, chloride is it's a +1, Cl a -1, so that's your formula. Mass of that, and it says dissolved in this volume to make that concentration. Same type of problem. They're giving you the volume, but you got to change that to liters, put that in there. They're giving you the concentration, that goes in there. Solve for moles and then change it to mass by multiplying by the molar mass of ammonium chloride. Okay, we come down here to molality. It says determine the molality. This time molality, remember, is moles of the solute divided by the kilograms of just the solvent. Okay? So molality, here we are given the grams of the acetone, and that is being dissolved into 620 grams of water. So you can just set up unit multipliers with this. 650 grams of acetone, you need to convert that to moles. So 1 mole divided by the molar mass of acetone. You're going to divide 560 divided by the molar mass. Then this is 560 grams for 620 grams of water. This is your water. This is your acetone. So this first unit multiplier is going to give you the correct moles of the acetone, but you don't want 620 grams of water, you want kilograms. So you have to convert to kilograms, 1,000 grams of water in a kilogram. So that's going to give you then kilograms of water. Okay, your grams will cancel here, and you'll have moles per kilogram of the water. Molality, here we've got, again, 12.9 grams of the fructose in that amount of water, that mass of water. You're doing exactly the same thing. You have to convert the 12.9 grams to moles using the molar mass of the fructose, and then you have to divide by kilograms of water. So you have to convert that to kilograms, convert 31.0 grams to kilograms of water. How many moles? This time you're asked to find moles. Must be dissolved in 125 grams of ethanol in order to produce 12.0 concentration. This is molal, concentration of 2-butanol solution. Okay? So basically you're looking at molal is moles over kilograms of water, or actually it's kilograms of ethanol. Okay? So you are given the molals. This 12 is the concentration. That's molals. And then you are also given the mass of the ethanol. Convert 125 grams to kilograms and put that in here. Solve for moles. You'll have the number of moles. Then once you know moles, you need to convert that to mass by multiplying by the molar mass of that 2-butanol. And this is the formula right here. So you got to take that formula and find the molar mass of that monster and multiply the number of moles by that to get the total mass in grams. Okay? So work through those and check all of these. Make sure you got the correct answers, and let me know if you have any questions.